Hi, everyone. This is our last lecture for this part of the term. The next class session will be meeting for our second midterm exam. That will be this Thursday, so be aware that that will be happening. When I upload this recording, I will also upload a study guide. Be aware that the exam will be open from 6 in the morning until 9 o'clock in the evening, but um, if you uh, once you log in, you have to complete it in a single setting, and you will have a 2 hour window for that. So you won't be able to take it over the entire span of time that it's open. So look at when you're available, pick a time between 6 a.m. and let's say 7 o'clock p.m. because the exam will close at 9 and you want to have time to complete it before the exam goes dark. I will again upload a study guide that will provide information on all this, but be aware that in a couple of days, Thursday of this week is going to be our second midterm. With that, this is the last lecture of material that will be covered on the midterm. Keep in mind that the midterm is not cumulative, so it's only covering material that we've discussed since the first midterm. That said, if concepts that we introduced during the first part of the term come up again in the second part of the term, then they're fair game. With that in mind, let's talk about environmental health and toxicology. And you guys, just by virtue of being where you are and when you are familiar with some of this, particularly with the COVID-19 pandemic, which actually, as we will show in a moment, is still ongoing. I know we talk about after the pandemic or post-pandemic, but in fact, what we're talking about is pre-vaccine and post-vaccine, but the virus is still very much out there and the pandemic is still very much ongoing. Nevertheless, let's talk about the COVID-19 virus, which is believed by many, not by everyone, but by many, to have had a zoonotic origin, which means it's coming from other living things. And it has a close genetic similarity to bat coronaviruses, which suggests that it emerged as a bat-borne virus and that it was humans encountering bats that led to the introduction of the COVID-19 virus into human beings. The virus doesn't show a lot of genetic diversity, which indicates that it's probably a relatively recent phenomenon, a relatively young virus, if you want to phrase it that way. And so that suggests that the spillover events where humans started becoming infected with the virus was relatively recent, probably in late 2019. Current figures that are available online that I can find show that globally there are over 7 million deaths from COVID-19. Now, this number, I was back during the pandemic and after we had the vaccine, I was keeping this updated every single term. And so that way you could see the progression of the rate of death during again, the ongoing pandemic. I can't do that anymore because the numbers aren't being updated. So this is the same number that I had available to me when I taught this course back in spring of this year. And online, at least my sources listed down there at the bottom are not updating this. So this is what we have available. Nevertheless, it lets you know how many have died in general globally, over 7 million people. Over a million deaths, 1.2 million deaths in the United States alone. So the United States was pretty dramatically impacted by the COVID-19 virus. More locally, there were over 8,000 deaths in San Bernardino County and over 8,000 deaths in Riverside County. So if you live in either of those areas, be aware that the COVID-19 virus hit those areas pretty hard. So those numbers really demonstrate that this is a significantly dangerous virus. Once the vaccine became available, it became fairly common, and I think it still is fairly common to discuss COVID as, not much worse than a cold. It's just the sniffles, things like that. That's actually not the case. It can have serious health impacts for a number of people, not just the elderly, not just the immunocompromised, but pretty much anybody is susceptible. The problem is that you right now listening to this could actually be infected, but you could be asymptomatic. You simply aren't really feeling the effects, even though you're carrying and potentially transmitting a live version of the virus. And that's why protection from this sort of thing is so important. As I mentioned, while we tend to hear online and on news and so forth that we are in a post-pandemic stage and that the pandemic is behind us, keep in mind this is how many deaths were reported across the world just last month, just September. That's over 1,000 people globally dying from the COVID-19 virus, of which 894, a huge percentage, were right here in the United States. And so there are still people losing their lives as a consequence of being infected by the COVID-19 virus. This shows a graphic representation of where we're finding the most of these deaths, not just infections, but deaths. And you can see that here, globally, the United States has the highest rate of death during the month of September. So once again, we are still in the pandemic. It may not feel like it. You may not want to think about it that way, but that is absolutely the case. And this is why it's been recommended, though largely this is ignored, and I'm not trying to be critical of any of you. Again, this is a remote virtual asynchronous class, so I have no idea what your mitigation practices might be. But during the height of the pandemic, it was recommended that you wear masks, specifically masks that can help block some of the virus or most of the virus, so that even if you are infectious but asymptomatic, you aren't necessarily transmitting it to other people. And if you are exposed to other people who are asymptomatic but who are transmitting the virus, you won't necessarily inhale it. So masks were recommended, and so were vaccines. And as an aside, the most recent vaccine, the most recent version of the vaccine is recently available for some people. It's been recommended for people over 65. That's one recommendation. But if you have other health issues, if you're compromised in other ways, if you are immunocompromised, if you have health issues, if you have weight issues, then you should be able to get the vaccine, which I would recommend that you do, because the vaccine helps teach your body to recognize the virus and to fight against it. And it's an effective way of doing this rather than running the risk of serious injury or even death by exposing yourself to the live virus. The thing is, in order for the vaccine to work, enough people have to be vaccinated to reach what's been called herd immunity. And this is a graphic from 2020 that was describing how herd immunity works, where if enough people get vaccinated or develop immunity, then it's very, very difficult for the virus to transmit from one person to the next and to infect whole communities. So you want to increase the vaccination rate so that you are reaching herd immunity and preventing the transmission of this disease. And back at the height of, you can see that this is from early 2021. This is an estimate of the kind of vaccination that would be necessary to reach herd immunity. And herd immunity is up there around 70%, 80%. And so if you can get the vaccination rate up to maybe 65, 70%, then enough people are vaccinated so that the virus, even if somebody gets infected, they can't necessarily pass it along to other people. And then it doesn't make it through those other people to other people who are immunocompromised or otherwise at risk from the virus. And so these were the recommendations that were given at the time. If you're wondering how we're doing on vaccination rates now, actually, it's pretty abysmal. This is from 2024, 2025 up through April of this year, and you can see that the vaccination rates are down there around 20%, which means even if you were getting vaccinated, you aren't necessarily preventing transmission of the disease. because other people around you may or may not be vaccinated, they may or may not be infected, and the vaccination program doesn't necessarily work unless everybody is on the same page and working to get that vaccine. So keep in mind that still the pandemic is ongoing and still people are at risk. Over and above that, there's a phenomenon that's been described called long COVID, where in some individuals you get permanent impacts or at least long-term impacts. The reason I hesitate calling it permanent is because we don't know, because it's 2025 and this thing started showing up, as we discussed, in early 2020, which means it's difficult to describe long-term phenomena because it hasn't been a prolonged period of time. We don't know how this virus will affect people 10 years after infection, 20 years after infection, because we aren't there yet. It's going to be a learning experience for all of us to see how that transpires. But even now, it's been documented that there are some people who have long-term impacts from being infected by the virus. And these are just some of them where you have fever, fatigue, brain fog, headache, chest pain, shortness of breath, loss of appetite, and so on. And these are not something that are short term. These aren't something that happen just when you're infected. They also show up for a prolonged period of time after you're no longer testing positive for the virus. So it really can, for some people, have long-term impacts. As an aside, if you are experiencing any of these symptoms and you have had COVID at some point, you might wish to investigate whether or not long COVID is something that has impacted you that maybe you just haven't thought of yet. This is the sort of thing that needs to happen in order to fight that is reporting, recognition, and research, specifically research, which is recognizing the importance of vaccination, the importance of understanding the symptoms, the importance of understanding transmission, and addressing all of that. As I've mentioned, the real challenge there is going to be the current low rate of vaccination, which means as long as this virus keeps promoting itself, we're going to continue to have issues like this. Speaking of viruses, what is a virus? Now, moving beyond the COVID-19 information, though I may very well test you on that, but I'm definitely going to test you on this because I want you to know what viruses are versus other things. Viruses are generally thought to be non-living. There are some scientists who would argue that technically you might think of them as living things. But for our purposes, it's a likely non-living parasite. We talked about parasitism earlier, and it's made up of genetic material contained within an organic particle. And where the definition of life comes in and why there is a challenge is that viruses can't reproduce on their own. They need a host body. They need to infect a host body in order to be able to successfully reproduce. And so that's where people who study viruses tend to draw the line between being alive and not necessarily being alive. It's that ability to reproduce. They absolutely can't reproduce on their own. And so, as a consequence, there is an evolutionary drive for them to continue to invade other organisms and then find new ways to adapt to invading other organisms and infecting them, and then taking advantage of the energy that those organisms use for their metabolism and using that themselves in order to produce subsequent generations of viral particles. And so that is the key difference to keep in mind between viruses and what we're going to talk about in a moment, bacteria. When I talk about this on the exam, it's that viruses cannot reproduce on their own. All right, that's an important point. Now, I just gave you the numbers for how badly COVID-19 has impacted us, particularly here in the United States, and how badly it still is impacting us here in the United States. But that doesn't mean viruses haven't also had major impacts in the past. And so We have focused a lot in during this term on the ancient Roman Empire. I have read online that maybe old people like me talk too much about the ancient Roman Empire, so forgive me if I talk about it again. But the reason I'm bringing up the empire now is because there is a recorded historical event, good Lord, not hysterical, historical, known as the Antonine Plague, which took place between 165 and 180 in the Common Era. And this was actually documented by a observant individual named Galen of Pergamon, who was able to study, look at, and then record the symptoms that are associated with this plague. And those symptoms include fever, vomiting, diarrhea, and blisters or pustules on the skin. And so now, today, scientists are able to look at these symptoms, and they've, based on that and other analyses of some of the remains that they've determined that basically this plague was caused by probably smallpox, but also possibly measles. And that's because those are the characteristics that we see when smallpox or measles infect people today. Back then, because they didn't have vaccines, because they didn't have medicine, and because they didn't know how viruses transmitted themselves, they didn't have germ theory. They didn't have any of the understanding of viruses that we have today. And so their practices weren't necessarily effective at preventing the transmission of viruses like smallpox or measles. And so as a consequence, this plague was very potent. It was the first known pandemic that impacted the Roman Empire. There were up to 2,000 Romans dying every day, which is an enormous impact on that society. The total death count is estimated to have been from about 5 million to 10 million people, or about 10% of the entire population. Keep in mind, we just discussed COVID-19 earlier, where we talked about the number of deaths that we had globally and the number of deaths that we had in the United States. This is far more severe and over a somewhat smaller area. So this was a huge health issue for the Romans. Now, smallpox and measles can be sort of similar. That's why people are still discussing whether this plague was a consequence of being from smallpox or being from measles. In either event, though, we don't deal with these quite as much today because we have vaccines for smallpox and we have vaccines for measles. And so we are able to work again to administer vaccines and protect against the spread of these infections so that we don't see that same deadly pulse that the ancient Roman Empire saw. That said, with the vaccine hesitancy that came up with COVID-19, we've also seen recently vaccine hesitancy with other vaccines, like the smallpox vaccine, like the measles vaccine. And so these are data as of September, mid-September of this year. And you can see the difference, especially over there on the right, in terms of numbers of cases from about 2000, the year 2000, up to the current year. And you can see that right now we're having a huge spike in it. The last spike was just prior to 2020, in 2019, where there was a reduction in vaccination and a huge surge in measles cases. And in this case, you look at that graph, please realize that we are still in October. So the year isn't over yet. This is not a complete picture for the number of cases, measles cases that we are going to have this year. And then when you compare that to the years 2000, 2005, 2010, you can see that back then, because of the high vaccination and because of the herd immunity phenomenon, measles were very, very, very rare. And now clearly that is not the case. And this is a consequence of people not vaccinating. And as a consequence of that, herd immunity is not working as effectively as it is supposed to. Now, that was discussions of viruses. Now we're talking about bacteria. And bacteria are a little different. They are alive. They're single-celled organisms that have cell walls. They lack a nucleus, and they can reproduce independently. They reproduce asexually. We will talk about that more in a future lecture. What they do is they secrete or excrete or otherwise produce toxins that then get into the host body and then hurt or attack the host body. So here, they're capable of reproducing independently, but the byproducts of their existence are what is impacting human beings. And so in this case, you might be asking, okay, have there been any historic incidents of bacterial infections having a strong impact on ancient human societies? And you're probably thinking maybe something besides the ancient Roman Empire. And so I'm going to disappoint you and talk about the ancient Roman Empire because there was a different, somewhat younger plague. This is the plague of Justinian from 541 to 549 in the Common Era. And this was characterized by fever, chills, disorientation, and swollen, oozing lymph nodes, also known as buboes. And that last symptom should be the one that gives away what this is. When you have buboes developing on your body, that means that this is most likely going to be bubonic plague. And so here's long before the classic bubonic plague that we all read about. Here's in ancient Rome in the 500 part of the current era. You have ancient Rome being devastated by the influx of bubonic plague, and it really did dramatically impact society. It's the first known plague pandemic in the old world. There were as many as 5,000 deaths per day in Constantinople, which is present-day Istanbul. The total death count is estimated to have been about 15 to 50 million people. So it could have been as much as 25% of the total population because the bubonic plague, I mean, again, we've talked about the bubonic plague or the Black Plague in more recent times, but it's just as vicious in ancient Rome as it was more recently. So here you have an example of a bacterial infection causing this sort of dramatic death in ancient societies. I mentioned maybe we can talk about something else. There are other impacts that other civilizations have felt. For example, the Aztec Empire, much more recently in the years 1545 to 1549 in the Common Era, experienced what they know, what's been called the Coco-Liztli pestilence. And this was characterized by fever, headache, vertigo, black tongue, dysentery, head and neck nodules, jaundice, profuse bleeding from the nose, eyes, and mouth. I'm not going to ask you to remember these characteristics. The point of all this is to show you that some of these infections can have massive impacts on ancient societies. And that's the point that I want you to remember. So don't worry that I'm going to ask you to tell the difference between bubonic plague versus smallpox. Or anything along those lines. Nevertheless, because we have this documented and we know what the various symptoms are, it's been determined that this is most likely the best consideration of what was driving this is salmonella, which you wouldn't necessarily think of as being all that deadly, but it absolutely was. It was a huge plague that really badly impacted people because they didn't have any resistance to it. Here's a study from 2018 that talks about the genomes that show up from this time period. And the indication is that Salmonella is a strong candidate for the population decline at that time. Now, this is what I will test you on. These are the characteristics I want you to remember, is that viruses are not living, as we discussed. Bacteria are living. Viruses cannot reproduce on their own. Bacteria can reproduce on their own. Viruses are submicroscopic. Bacteria are huge compared to viruses. And a viral infection is systemic. And hopefully you've noticed this. If you get a virus and it makes you sick, you are all over sick. Your whole body hurts. If you caught COVID, you've caught the flu, you generally feel miserable and your whole body's infected. Whereas with a bacterial infection, for example, food poisoning, things like that, it's often localized because the bacteria are producing those toxins in some parts of your body, and that's where things get impacted. So, a bacterial infection will be more localized, whereas a viral infection will be systemic. And down at the bottom, in both cases, you've got examples of diseases. I probably won't test you on that. Again, I don't want you going in and thinking, oh my gosh, is pneumonia bacterial or viral? I'm not going to ask you that. That's not the point of this lecture, but I do want you to be aware of the differences. So, viral infections are contagious because that's the whole evolutionary strategy of viruses is to spread from one host body to another because if they don't do that, they can't reproduce. Whereas bacteria, it's not necessarily the case that they need to spread from one body to another. Viruses cannot be treated with antibiotics. By definition, antibiotics are designed to eliminate living things, and viruses are, according to most studies, not living, whereas bacteria can be eliminated with antibiotics. And again, there are some examples at the bottom. Colds, flu, chickenpox, COVID-19 versus strep throat, pneumonia, and UTIs would be an example of a bacterial infection. These are also important points. Vaccines are used to prevent against diseases. This is actually the big one. Vaccines are preventative. If you get a vaccine, it helps reduce your likelihood of contracting the disease. And if you still do contract it, it will usually help reduce the effects of it. That doesn't mean every vaccine always works perfectly 100%. That simply doesn't happen. But in most cases, if you are taking vaccines, then your likelihood of developing the disease are reduced. And if you do get infected, then the likelihood of it being severe is reduced. But it is preventative. You try to get it in advance, whereas antibiotics are reactive. Once you are ill, once you have pneumonia, strep throat, what have you, then you're taking antibiotics to fight the disease off. Because vaccines are preventative, they're efficient in disease control. You go into areas where disease might be spreading, you get people vaccinated, and through herd immunity, it prevents the widespread distribution of that disease. Whereas antibiotics, because they're reactive, it depends on the time of treatment relative to the time of infection. Vaccines do not induce bacterial resistance. Antibiotics do cause bacteria to become resistant. We'll talk about that in a moment. There are a variety of other issues, no food safety concerns for vaccines, whereas with antibiotics, there can be food safety issues. Um, Herd immunity works with vaccines. It's not necessarily as effective with antibiotics. You can be environmentally sustainable with vaccines, not so much with antibiotics. And again, vaccines are recommended for disease control. All right. But that's the big one I want you to remember is that vaccines are preventative and antibiotics are not. Right? Write that down. Antibiotics are not preventative. Why am I emphasizing this? Number one, for the exam. Number two, how many of you use antibacterial soap? And the answer is probably going to be most of you, because this is what you find at the store. Almost all soaps these days advertise themselves as being antibacterial. And the whole thinking behind it is if I'm using antibacterial soap, I am reducing the likelihood of getting sick. And the reason that that is an issue is because, as I just described, antibiotics or antibacterials are not preventative. They don't reduce your likelihood of getting sick. They are reactive to when you are already sick. And so, as an example, this is a antibacterial soap, and it's for hand washing to decrease bacteria on the skin. And that's true. It will eliminate bacteria, but it's not preventing it. As soon as your hands start encountering other things, you're going to get more bacteria. And if they are dangerous, if they're infectious, then you might still get sick because this isn't preventative. Now, I want you to notice what the active ingredient is. That's something called triclosan, and it is an antibacterial agent. The reason I want to mention that is that here's another study from way back in 2007, the long ago time of 2007, that essentially looks at triclosan and asks whether these are effective in reducing disease or perhaps not. And their conclusion, soaps containing triclosan, and you can read this, were no more effective than plain soap at preventing infectious illness symptoms. Laboratories demonstrated evidence of triclosan adapted cross resistance to antibiotics, meaning number one, it was giving you no benefit. It was not helping to reduce disease because it's not preventative, but here you've actually got documentation that I'm not just making it up, that these things don't, there was no difference between antibacterial soap with triclosan and plain soap with no antibacterial agents. But what did happen is that the bacteria that you did have on your hands would, by being increasingly and constantly exposed to the triclosan, some of them would develop resistance. We talked about that in an earlier lecture where you have some pests developing pesticide resistance. Well, that's exactly what's happening here is the bacteria are becoming resistant to triclosan and other antibiotics through the constant application of triclosan in antibacterial soap. And what happens is you have a bacteria and then you have an indiscriminate use of antibiotics. And in this case, it's indiscriminate because people generally are using it with the thinking that it will help reduce the possibility of them being sick because they don't recognize that antibiotics are reactive to being infected, not preventative. But the bacteria keep getting exposed. And if the biotics are just being used over, the antibiotics are just being used over and over and over and over and over, then eventually the few bacteria that have a little bit more resistance to that will then pass that resistance on to their offspring, that then will pass it on to the next generation, that then will pass it on to the next generation, and eventually you end up with super bacteria. We talked about this in a previous lecture where we mentioned the pesticide treadmill. This is the antibacterial treadmill where you're getting antibacterial resistance from the bacteria that are essentially the targets. And so this is what happens with antibiotic resistance. It's overprescribing antibiotics, it's patients not finishing their treatment, it's overuse of antibiotics, it's lack of hygiene, and it's the last one on this chart is a big one. It's the lack of new antibiotics being developed because I think there is this idea that if you get sick, if you get an infection, you go to the store, you get the antibiotics, or you get it prescribed by your doctor, and you should be okay. And yet, there's not a lot of research going into developing new antibiotics, or if you're from England, antimicrobials. I mention that because I just showed you how by the indiscriminate application of antibiotics like antibacterial soap, you're creating super resistant bacteria. And then, if on top of that you aren't investigating new forms of antibiotics, then you're essentially letting those bacteria romp free. And yet, this is showing from a few years ago, 2003 to 2013, how much money was invested in research and development in pharmaceutical companies and how much of that was antimicrobial investment. And it's a tiny fraction of the overall investment. So obviously, pharmaceutical firms are conducting a lot of research and development, but very little of that is dedicated towards actually developing new antibiotic agents that are working on defeating these super bacteria that are being developed through our own practices. And so it's been estimated that you can have antimicrobial resistance really, really growing. These are looking at different things, deaths per year, and you can see that as antimicrobial resistance grows, as people get continually sicker because even with antibiotics, they aren't able to fight off infections. As long as we aren't developing new antibiotics or new antimicrobials, you're going to continue to have this increase in the death rate as a consequence of that. If you look back in not ancient times, you look back in historic times, prior to the advent of our understanding of germs, prior to the development of antibiotic agents, and there were doctors, and they would perform surgery, and the surgery could be relatively straightforward. And then the big concern afterwards is, did we avoid infection? And in many cases, no, they didn't. So, yes, the surgery is a success. Yes, we removed the appendix or we removed whatever. But then an infection sets in because they have nothing with which to fight it. The patient ends up dying. It was the development of antibiotics and the recognition of how these diseases were being transmitted that enabled that to stop. But with this treadmill of antibiotics, we're losing that efficiency. I'm going to get a little personal now, and I apologize if this makes you uncomfortable. But a few years ago, I lost a friend of mine who worked with me when I was the curator at the county museum. And what I just described is exactly what happened. She needed surgery. She was having digestive issues. I believe there was an obstruction. And so she needed to go in for surgery. And she was not that old. And she went in, and the surgery was a complete success, but an infection set in, and they couldn't beat it. They gave her antibiotics, they shifted to different kinds of antibiotics, and this went on for weeks. So she goes into the hospital. The next day, she notifies me and her family and others. Everything went fine. I'm recovering. I'm doing great. And then there was an infection, so I need to stay here, and they're going to treat that, but I'll be out in a few days. And then it was a week, and then it was 2 weeks, and then it was 3 weeks, and then she passed away. And it's because whatever bacteria were making her sick had infected her after the operation. They were resistant to all of the available antibiotics that were being used to fight the infection. And so, what I'm talking about may sound abstract, but it's actually very real. So, please keep that in mind when you are using antibacterial soaps and other things. You really don't need to. It's not helping, and it might even be causing damage down the road. Now, in terms of how some of these different things are transmitted, we've already talked about COVID-19, and it's thought to have been of zoonotic origin, probably from infected bats. And a recent report, there's been a lot of discussion about this, and it goes back and forth and back and forth. Some people have suggested that it wasn't a natural occurrence, that it leaked from a lab. Some people have suggested that it might have been deliberately designed. But according to the World Health Organization, and this is a report from June of this year, you can see there that what they say is based on the available evidence, the weight of the evidence suggests zoonotic spillover either directly from bats or through an intermediate host. Now, whether those bats were in the wild or whether they were in a market being sold as food, that's a different subject, but it doesn't appear to have been, at least according to the weight of the available evidence, according to the World Health Organization, it doesn't appear to have been a lab produced event, and it doesn't appear to have been a deliberate thing. But this sort of transmission is increasingly common because it's not just COVID-19. If you think about the Ebola virus, that was actually passed to humans from infected chimpanzees. Now, the chimpanzees themselves might have got it from other organisms, and the possibility is that they got it from infected bats. And so there are caves in some parts of Africa that are thought to be riddled with bats that then transmitted Ebola to chimpanzees, and then humans picked it up from the chimpanzees. That's the Ebola virus. There's the AIDS virus it's the same thing. It was passed to humans from infected monkeys, is the current thinking. And so, again, as these viruses and illnesses are being transmitted, it's not just the Chinese markets, the food markets, or what have you. It's happening with a variety of deadly diseases, and it's happening mainly through zoonotic transmission. And I bring that up because humans are continuing to get involved with areas where these animals live. And we're doing it because of our consumption patterns, because we are moving into these areas because they have wood available, they have other resources available. And so we move into some of these dense rainforests and we start cutting things down. And that's commerce. That's the way it works. But what happens is people are moving into these areas. People have lived there, and now industrially, civilizations are moving in and taking even more advantage of it. So these people are exposed, and as say timber companies are moving in and cutting things down and opening up new areas, people like this are expanding into those areas because why wouldn't you? It's more room to maneuver, it's more room to grow. And we've talked about that in our earlier lecture, where that is basically what humans are doing because of where we are on the trophic hierarchy versus our ancestry as being primary consumers. Now we are consuming much more meat. And as a consequence, our populations are growing, becoming more dense. So as new areas open up, due to resource consumption, we people move into those areas. And as they encounter new meat sources, they take advantage of the meat sources. And one of those meat sources that people in these areas are consuming is apes, things like chimpanzees, things like gorillas, which we think of as remarkable animals. You can see that this book, if you want to read this book, you can. Be advised that it is extraordinarily graphic and, in my view, extraordinarily depressing. But it lets you know what's going on in certain parts of the world. And you can see that it was recommended by the recently deceased Jane Goodall. Jane Goodall is responsible for promoting our understanding of chimpanzees, the way we see them, the way we think of them, the way we recognize our kinship with them and their intelligence and so on. But in terms of the people living adjacent to chimpanzees, they are also a source of food. They are a source of protein. They are a source of energy. And if you take advantage of that, and those animals have been infected with viruses, then you have that issue as well, where potentially those diseases are spreading. Now, what you could do to help would be to reduce the consumption of the forests, reduce our impacts on those forests. But you have to realize that you have people living there who depend on these resources for their lives. And it would be the height of arrogance to come in and tell them, no, you may not do that without providing some other mechanism for them to survive and thrive. And so this is a very thorny issue going on right now, but it's why we are likely to see more and more diseases of this nature infecting human beings. It's an almost inevitable consequence of our consumptive abilities and our population expansion tendencies working in synchronicity to expose us to more and more of these viruses. Even if you were to regulate forest consumption, that's been done to marshal the resources and preserve them. Nevertheless, there are people who will work around that. There's illegal logging that moves into these areas and causes the same sort of damage. So even if you get away from uh, uh, timber companies and so on moving into these areas and opening up new avenues for these diseases to become manifest, even without that or with that being reduced, you're still going to potentially see these impacts because of illegal activities in these areas as well. Now, this is that's been a brief discussion of how we are impacted by things like viruses and bacteria. Now I want to turn it around and look at how we are, in our turn, impacting the natural environment. And as humans continue to expand, as our various societies grow and expand, and we make more room for them, we are impacting the natural world as well. And generally speaking, you think about things like garbage and so on being distributed, but we're also, this is a biology class, we are also distributing other agents as well. For example, chemicals. We use chemicals. We just had a lecture on pesticides, and we use them in order to control pests, to control disease, to do any number of things. Natural chemicals have always been with us, but usually when we use things for our own purposes, we refine them and make them even stronger. Now, in the United States, around 53,500 chemicals are currently being used. If you're going to use a chemical, you actually need to test to see whether it's going to make people sick. And if it's going to make people sick, you need to tell them what to do about it. Probably you have worked with this for those of you who work with chemicals in your workplace, which is going to be most of you. Probably you have dealt with this before, where you need to know how to respond. Many of you might have a workplace that has an eye wash station in case you get something in your eyes. You're probably used to that. Or you're told to wear gloves, or you're told to wear safety glasses because otherwise you're exposed to these hazards. But as it happens, less than about 20% of all of those chemicals in the US are tested for acute effects, and less than 10% are tested for chronic effects. And I want you to remember those numbers. In case you're wondering what those terms mean, acute effects mean immediate effects. If you were to drink poison accidentally, you're going to have an immediate response. It's going to hit you right off the bat. That's why there are any number of poisons. Like if I were accidentally at home and reaching for a bottle of something to drink, and instead of something to drink, I grabbed uh, toilet bowl cleaner, something like that. If I accidentally drink that because I'm an idiot, I am going to have a very immediate response, and my wife's going to be very upset with me. That is an acute effect. But you also have chronic effects, and this is what can happen when you are exposed to harmful characters over a prolonged period of time. Depending on the chemical, we don't necessarily know how long it might take. But for example, people who smoke and are exposed to the chemicals in cigarettes, they don't immediately develop lung cancer. And in some cases, they may never develop lung cancer or throat cancer or tongue cancer. But repeated exposure over a prolonged period of time might cause them to develop cancer in various parts. We'll talk about cancer in a moment, but that is the difference between acute effects and chronic effects. Acute effects are immediate, chronic effects are longer term. And so, for those of you who work with chemicals, you might be familiar with sheets like this that you're required to have at your company where you are working with chemicals. And these are safety data sheets. Okay. And they tell you what is the chemical, what are the active ingredients, what does it do, and what are the potential effects. And I'm picking this one to one trichloroethane, because I used to use it. Way back when I worked at the La Brea tar pits, I was running the excavation there. This is back in the 1980s. And that's me holding a direwolf skull that we had just excavated in the 1980s, probably the later 1980s. And to get the asphalt off of that skull and off of my hands and out of my clothes, I was using 1 to 1 trichloroethane. And I didn't make that up on my own. That was the standard procedure at the tar pits at the time. That's what everybody was using to clean stuff. And we were aware that there were health issues, potential acute health effects. Number one, if I drink it, it's poison. I need a poison control center right off the bat. That's an acute effect. If I get it in my eyes, I need an eye wash station right away. That's an acute effect. It's going to really, there's a variety of ways it could really hit me. Now, there were also chronic effects, and the chronic effects involve drying out your skin and your fingernails starting to crack, because the whole point of this substance is to break down oil. So if you have oil on your skin and you're using this material, it's going to destroy the normal oil that your body is producing. And so you end up with very dry skin. If you keep using it, you get flaky skin and cracked skin, and then your skin pulls back from your fingernails and your fingernails get brittle. That's the chronic impact. Now, I bring this up because you see the potential chronic health effects, and if you look down there, it says carcinogenic, not available. Okay, mutagenic, not available. We're going to talk about those. But this is an old data sheet. And shortly after I left the tar pits to come out to the San Bernardino County Museum, it was determined that trichloroethane was carcinogenic. It caused cancer, and that is a chronic effect. And so it does have a chronic effect. And so it was determined that actually this is a very dangerous substance to use. And at that point, the folks at the tar pit said, we need to find something else to clean our fossils. We aren't going to use trichloroethane anymore. And so all of those years, I was washing my hands and cleaning fossils and cleaning my clothes using this material on a daily basis. I was exposing myself to a carcinogen, not because I'm stupid, but because at the time nobody was aware of uh, the carcinogenic impacts. And the reason they weren't is because chronic effects, long-term effects, take a while to figure out. If you're using a chemical and it has impacts that only move in after about 5 years or after 10 years or after 20 years, then you have to have been using that chemical for that period of time, right? And so this gets back to why only 10% of chemicals have been tested for chronic effects. It's because you need to actively start using the chemical and seeing what the effects are over years and over decades. And that's one of the reasons that so few chemicals are tested for chronic health effects, at least initially when they are released and when they start being sold. In the case of 1-to-1-to-1 trichloroethane, once it was recognized that it was a carcinogen, a lot of people stopped using it, particularly people who dealt with fossils that were trapped in tar pits. So, but that's because the studies couldn't be done in advance because you're looking for chronic impacts, not acute impacts. It was easy. I'm not saying they did this, but they wouldn't say, "Hey, Fred, drink this. Let's see what happens." That's not how it works. But it would be easy to see acute effects. It's very difficult to see chronic effects, and it's difficult to make connections. If I find out next week that I have cancer, would it be because of my decades-long exposure to this chemical back when I was using it, and it's just now that those effects are showing up? Or would it be any number of other things that I've been exposed to? It would be very difficult to relate that cancer to this particular chemical. And so, because chronic health effects show up over a prolonged period, and because it is difficult to relate specific health issues to previous exposures to chemicals in a chronic sense, that's why so few of these are being tested. Now, little bit of a change. I don't know how many of you recognize this skyline because I'm old and probably most of you are not. Here's another out-of-date pop culture reference, and I apologize. It's the best I can do. And for those of you who have not seen this movie, spoilers ahead, so maybe plug your ears. I'll try not to test you on aspects of the movie in the exam, though I might, because it was in 1989 a fairly popular movie. It was the first Tim Burton Batman movie, and for those of you who have not seen it, this is a good time to look away and maybe cover your ears. But for those of you who have seen it, hopefully you remember it, and what you might remember is that the Joker was the main villain, and what the Joker was doing was poisoning Gotham, but nobody could figure out how he was doing it. People ended up being infected with a substance called Smiley. And this is how they ended up, and they developed this grinning rictus, and then they would die. And nobody knew where it was coming from. How is this chemical being administered? Is it in our food? Is it in our water? Is it in chemicals that we're using? And so people stopped using some of the normal things that they use, like hairspray, like shampoo, like soap, like makeup, because they didn't know where this was coming in. Now, spoiler alert. Again, if you haven't seen the movie, I'm giving it away and I apologize, but I'm making a point because Batman figured it out. Batman, the detective, is the one who figured it out. And what he figured out is that the Joker was combining things. So a shampoo and lipstick, each of them separately wouldn't do anything. But if somebody washed their hair with that shampoo and then later applied the lipstick, the two of those chemicals would interact to make those people sick and cause them to die. So it was a synergistic effect. It wasn't just one chemical or another. It was both of them working together in ways that neither one of them worked by itself. And so these effects, in addition to acute effects and chronic effects, synergistic effects. Yes, you will be tested on this. And the reason I bring this up is because it's when two or more substances react together in ways that they wouldn't act separately. That's the definition. Now, if only about 20% of chemicals have been tested for acute effects and only about 10% have been tested for chronic effects, how many do you think might have been tested for synergistic effects? And there are some where it's going to happen, but in terms of percentages, it's essentially zero. For the same reason I just described, for every chemical that might have a chronic effect, in addition to that effect, you would also have to test that character against every single one of the other 53,500 or so chemicals that are in use in the United States, as an example. And that's prohibitively time consuming and expensive. This is why so many chemicals have warnings on them that say, this may do this, this may do that, this may do the other. It's basically covering your butt. It's like if something happens to you that we didn't anticipate, it's not our fault, and you agreed to do that when you purchased the product. And it's because you simply can't test all these chemicals for synergistic effects. There's too much. It's too big a question. So those are the three I want you to remember: acute, chronic, and synergistic. Now, speaking of that Batman movie, here's the villain, Joker. For those of you who have not seen the movie, still more spoilers ahead. But how did the Joker come to look like this? Well, he fell into a vat of a weird acid and it mutated him, right? It changed him. And so whatever chemical he fell into was a mutagen. It changed his genetic structure. That is an important point. That's an important part of the definition. Mutagens damage or alter genetic material. And because the genetic material itself is changed, those changes can be passed to your offspring. If you have a mutation, you can pass that along to your offspring. And there's no safe threshold to mutagens. You don't know how much is a safe area because any amount can affect your DNA, and you don't have any control over that. So know these facts. It changes your DNA, it can be inherited, and there is no safe threshold. And that's something to keep in mind next time you're watching superhero movies, and you'll notice now I'm switching over to the Marvel Universe just to be fair and balanced. I want you guys knowing I'm covering both sides of the superhero realms here. Um, but these are all mutants. These are individuals who have been mutated. I'm not sure what mutated Storm, but in the case of the Thing up there in the upper left, it was exposure to cosmic rays. I should update that with the new Fantastic Four movie so that it's not an out-of-date reference. And with the Hulk, it was exposure to gamma radiation. So they're exposed to these forms of radiation and they are altering the genetic structure of these people. I do not recommend that you stand next to gamma radiation or expose yourself to cosmic radiation and hope that you're going to get superpowers. It probably doesn't work that way terribly effectively. That said, as we discussed way back in our evolution lecture, mutation is a normal part of evolution. Your genetic content is going to be exposed to radiation simply by existing, and there are going to be some minor changes. And those minor changes don't necessarily manifest themselves to make you look like the Thing or the Hulk, but they nevertheless can then be transmitted to your offspring. And so this is one of the ways that natural selection works, is with populations that have built-in variation reproducing, and then random mutations are passed along to offspring And if they actually impact the offspring or hurt the offspring, then the offspring might not survive. But those that do survive then pass those changes along to their offspring. So that's something to keep in mind. Now, similar but different, and I will test you on the difference. Teratogens. These also cause developmental abnormalities, but the key difference here is that they do not affect the DNA. So examples of this would be alcohol, particularly if you were pregnant. This is why pregnant women are encouraged not to consume alcohol. It's because you can actually have developmental issues with your child because of the intake of alcohol, because alcohol in that context is a teratogen. Um, Cocaine is another one, and I put a pile of cocaine there. I did not take that picture myself. I found it online. I'm a little concerned because now my search history will say pile of cocaine, and I wonder who might be monitoring that. So if it was on a university computer, I'm a little concerned. But it gives you an example, a couple of example of chemicals that you can take into your body that can have a teratogenic effect. Alcohol and cocaine being two examples, but they don't change the DNA. They do not alter the DNA, which means any changes to bodies as a consequence of these chemicals are not passed along to the offspring. They aren't inheritable. And so that is the key difference between mutagens and teratogens. Mutagens cause changes in DNA that can be transmitted to subsequent generations. Teratogens cause developmental challenges, but they are not transmissible because they do not impact the DNA. Now, I bring that up, and now we're kind of circling back because remember triclosan, that antibacterial agent? Here's a paper from 2017, and it is talking about triclosan in maternal and umbilical blood samples causing fetal malformation. In other words, triclosan, that antibacterial agent in soap that is not necessarily effective, any more effective than plain soap, is also a teratogen. It also, by being constantly used, is having an impact on reproductive health in women. So, if you're buying antibacterial soap, I would encourage you not to, because you don't need it, because it's not going to do anything. Regular soap is going to be just fine. But if you still feel you'd rather do that, make sure that triclosan isn't one of the active ingredients in it. It shouldn't be. I think it's been eliminated, but it's always best to check. So that's teratogens. And I'm going to end up with carcinogens. And carcinogens basically are chemicals that cause invasive, out of control cell growth. Another term for invasive, out of control cell growth is a tumor. Cancer is the second leading cause of death in the United States, and it is estimated that around 30% of people in the United States now living will eventually develop cancer during their lifetimes. So, according to Canvas, I have 204 students in this class, which means between 50 and 60 students in this class are likely to develop cancer at some point in their lives. That's a horrible statistic. I know that my mother passed away back in 1991 as a consequence of cancer, bone marrow cancer. And not to take away from the human impact, but also if you have, in addition to family and friends, for those of you who might have pets, they get cancer as well. And it is a huge, I think almost every pet I've lost in the past 10, 15 years has been some form or another of cancer. So it really is prevalent. It can take decades to develop, and as I mentioned earlier, the cause and effect are difficult to determine. If I develop cancer next week, is it something that was hereditary because my mom had it? Is it something I picked up from being exposed to cigarette smoke from back in the 70s when smoking indoors was perfectly acceptable and everybody did it? And I'm just sitting there, I'm not smoking, but I'm certainly inhaling. Is it from exposure to 1 to 1 to 1 trichloroethane? Is it from any number of other things that I might have been exposed to over my life? It will be difficult to say this cancer is a consequence of that exposure if that exposure is decades in the past. There are many different kinds of cancer that affect different parts of the body, and carcinogens can be either organic or inorganic or even synergistic, where two chemicals coming together won't be carcinogenic in and of themselves, but working together they can be. And the important thing to remember about cancer, again, is not only do these chemicals impact us potentially, but if they get out into the natural world, they can impact organisms out there as well. And a perfect example of this that we have already talked about would be DDT. Back when they were spraying people with DDT because it was safe to ingest it, you could drink a soda and eat a hot dog and be surrounded by clouds of DDT and it wouldn't bug you. But we've already talked about bioaccumulation and biomagnification and how things get into the food chain and how they concentrate in higher trophic levels. And with us at the top, DDT would be a teratogen because it has the potential to impact the development of human embryos. It's also a carcinogen in those concentrations because it's also a cancer-causing agent, not from being sprayed like this, but from ingesting it through bioaccumulation and biomagnification. And as we are doing it, other higher trophic level organisms in the world are experiencing that same impact. And with that, I think that's it for tonight's lecture. Once again, if you have any questions, please feel free to reach out, let me know. And once again, please keep in mind that our next midterm, the second midterm, is coming up this Thursday. It will go live on Canvas at 6 in the morning and it will go dark on Canvas at 9 in the evening. If you have any questions, please reach out and we'll talk to you soon. Have a good evening and a good rest of your week.